The National Electrical Code, or NEC, permits a second electrical service specifically designated for emergency power systems. This second service must originate from a completely different source than the primary or normal power service. Its sole purpose is to provide electricity to essential loads during periods when the normal power supply is interrupted. The emergency power service must be adequately sized to handle the power demands of these critical loads. In the scenario presented, there is an existing 600 amp service at 208/120 volts, 3-phase. The project involves increasing the total service capacity to at least 900 amps. The question is whether the NEC allows a second service at 208/120 volts, also 3-phase, rated at 600 amps specifically for emergency power. The answer is yes, the NEC does allow this arrangement. This would result in two separate 600 amp services, one for normal power distribution and the other dedicated to emergency power. This configuration yields a total available power capacity of 1200 amps. The critical aspect is ensuring that the emergency power service is sized appropriately for the essential loads it will serve during a power outage. These essential loads commonly include, but are not limited to, emergency lighting to ensure safe egress, security systems to maintain building security, and fire pumps to provide adequate water pressure for fire suppression systems. The NEC mandates specific installation requirements for emergency power systems, which are detailed in Article 700. This article covers various aspects of emergency power systems, including the installation of emergency generators, automatic transfer switches, and other associated equipment. It is crucial to adhere to all the requirements outlined in Article 700 to ensure the emergency power system operates reliably and safely when needed. The requirement for a separate source for the emergency service is paramount. This is to prevent a single point of failure from disabling both the normal and emergency power systems simultaneously. Typically, the emergency power source is a generator, but it could also be an independent utility feed. The automatic transfer switch, or ATS, is a key component in an emergency power system. It automatically switches the essential loads from the normal power source to the emergency power source when a power outage is detected. The ATS must be designed and installed to reliably perform this transfer function. Regular testing and maintenance of the emergency power system are also crucial. This includes periodic testing of the generator ATS and other components to ensure they are in good working order. Maintenance should be performed in accordance with the manufacturer's recommendations and applicable codes and standards. The NEC provides detailed guidance on the types of loads that are permitted to be connected to the emergency power system. Generally, only essential loads that are necessary for life safety and property protection are allowed. Non-essential loads should not be connected to the emergency power system. The NEC also addresses the wiring methods and overcurrent protection requirements for emergency power systems. The wiring must be suitable for the intended application and must be protected from physical damage. Overcurrent protection devices such as circuit breakers and fuses must be properly sized and installed to protect the equipment and wiring from overloads and short circuits. In summary, when planning to install a second electrical service for emergency power, it is essential to carefully consider the following factors. Firstly, the emergency power service must be supplied from a source that is separate and independent from the normal power service. Secondly, the emergency power service must be sized to adequately handle the power demands of the essential loads that will be connected to it. Thirdly, the installation must comply with all applicable requirements of Article 700 of the NEC. Fourthly, ensure that the automatic transfer switch is properly selected and installed to automatically switch the essential loads to the emergency power source during a power outage. Fifthly, establish a regular testing and maintenance program to ensure the continued reliability of the emergency power system. By adhering to these guidelines, it is possible to safely and effectively install a second electrical service for emergency power, providing a reliable source of backup power for essential loads during a power outage. Remember to consult with a qualified electrical engineer or contractor to ensure that the installation meets all applicable codes and standards. Also, keep in mind that local amendments to the NEC may exist, so it's important to verify and adhere to any local requirements. The design and installation of emergency power systems require careful planning and execution to ensure that they function reliably when needed. A thorough understanding of the NEC requirements is essential for ensuring a safe and compliant installation. Furthermore, consider the long-term maintenance requirements of the emergency power system. Generators, transfer switches, and batteries all require periodic maintenance to ensure their continued reliability. A well-defined maintenance plan can help to prevent unexpected failures and ensure that the emergency power system is always ready to operate when needed. Consider the specific needs of the building and its occupants when designing the emergency power system. The types of essential loads that need to be powered during an outage will vary depending on the type of building and its use. For example, a hospital will have different emergency power requirements than an office building. Therefore, it is important to carefully assess the essential load requirements and design the emergency power system accordingly. Also, remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure the safety and reliability of the emergency power system. For example, it may be desirable to provide redundant power supplies or to use higher quality components than are required by the NEC. Ultimately, the goal is to design and install an emergency power system that will provide a reliable source of backup power for essential loads during a power outage, protecting the safety of building occupants and minimizing disruption to operations. In the given scenario, upgrading to at least 900 amps necessitates careful load calculations to determine the actual demand. A 600 amp emergency service, when added to the existing 600 amp normal service, provides 1200 amps total. This should provide adequate capacity assuming the load calculations support this. If the load calculations reveal that 1200 amps isn't sufficient, the emergency service amperage may need to be increased. However, increasing the emergency service beyond what's required can lead to unnecessary costs. Therefore, accurate load calculations are paramount. The 208/120 volt, 3-phase configuration is a common voltage system for commercial buildings. This voltage allows for both 208 volt loads, such as HVAC equipment and machinery, and 120 volt loads, such as lighting and receptacles. When designing the emergency power system, it's important to consider the voltage requirements of the essential loads. The emergency generator or other emergency power source must be capable of providing the correct voltage and phase configuration. In addition to the NEC requirements, there may be other applicable codes and standards that must be considered. These may include local building codes, fire codes, and accessibility requirements. It is important to consult with the local authorities to determine all applicable requirements. The emergency power system should be designed to minimize the risk of fire and electrical shock. All wiring and equipment must be properly installed and grounded. Overcurrent protection devices must be properly sized and installed to protect the equipment and wiring from overloads and short circuits. Regular inspections and testing of the emergency power system can help to identify potential problems before they cause a failure. Inspections should be performed by qualified personnel and should include a visual inspection of the equipment, testing of the generator and transfer switch, and verification of the battery voltage and charging system. Any problems that are identified during the inspection should be promptly corrected. Furthermore, ensure that the emergency power system is properly labeled. All components of the system, including the generator, transfer switch, and distribution panels, should be clearly labeled to indicate their function. This will help to ensure that the system is properly operated and maintained. Also, it's important to train building occupants on how to operate the emergency power system. This training should include instructions on how to start and stop the generator, how to operate the transfer switch, and how to respond to a power outage. Properly trained personnel can help to ensure that the emergency power system is used safely and effectively. Remember to document all aspects of the emergency power system, including the design, installation, testing, and maintenance. This documentation can be helpful for troubleshooting problems and for ensuring that the system is properly maintained over time. It can also be useful for demonstrating compliance with applicable codes and standards. When selecting an emergency generator, consider the following factors. Firstly, the size of the generator must be adequate to handle the power demands of the essential loads. Secondly, the generator must be reliable and durable. Thirdly, the generator must be easy to operate and maintain. Fourthly, the generator must comply with all applicable environmental regulations. There are many different types of emergency generators available, including gasoline generators, diesel generators, and natural gas generators. The best type of generator for a particular application will depend on the specific needs of the building and its occupants. When selecting a transfer switch, consider the following factors. Firstly, a transfer switch must be rated for the voltage and current of the emergency power system. Secondly, the transfer switch must be reliable and durable. Thirdly, the transfer switch must be easy to operate and maintain. Fourthly, the transfer switch must comply with all applicable codes and standards. There are two main types of transfer switches: automatic transfer switches and manual transfer switches. Automatic transfer switches automatically switch the essential loads from the normal power source to the emergency power source when a power outage is detected. Manual transfer switches require a person to manually switch the essential loads from the normal power source to the emergency power source. Automatic transfer switches are generally preferred for emergency power systems as they provide a more reliable and convenient way to switch to emergency power. However, manual transfer switches may be more appropriate for some applications, such as small buildings with few essential loads. In addition to the generator and transfer switch, there are a number of other components that may be required for an emergency power system. These may include batteries, battery chargers, inverters, and uninterruptible power supplies. Batteries are used to provide backup power for essential loads in the event of a power outage. Battery chargers are used to keep the batteries fully charged. Inverters are used to convert direct current power from the batteries to alternating current power for use by essential loads. Uninterruptible power supplies are used to provide a continuous source of power for critical loads, such as computers and medical equipment. These systems are often used to prevent data loss or equipment damage in the event of a power outage. The specific components that are required for an emergency power system will depend on the specific needs of the building and its occupants. It is important to consult with a qualified electrical engineer or contractor to determine the best combination of components for a particular application. When installing an emergency power system, it is important to follow all applicable codes and standards. The NEC provides detailed guidance on the installation of emergency power systems. In addition to the NEC, there may be other applicable codes and standards such as local building codes and fire codes. It is important to consult with the local authorities to determine all applicable requirements. The installation of an emergency power system should be performed by qualified personnel. A qualified electrical contractor will have the experience and knowledge necessary to install the system safely and correctly. The contractor should also be familiar with all applicable codes and standards. After the emergency power system has been installed, it is important to test it to ensure that it is working properly. The testing should include a visual inspection of the equipment, testing of the generator and transfer switch, and verification of the battery voltage and charging system. Any problems that are identified during the testing should be promptly corrected. Regular maintenance is essential for ensuring the continued reliability of the emergency power system. The maintenance should include a visual inspection of the equipment, testing of the generator and transfer switch, and verification of the battery voltage and charging system. The maintenance should be performed in accordance with the manufacturer's recommendations. A well-maintained emergency power system will provide a reliable source of backup power for essential loads during a power outage. In the scenario described, the existing 600 amp service is likely insufficient for the renovated bank. Banks typically have significant electrical loads due to computers, security systems, lighting, and HVAC equipment. Upgrading to a minimum of 900 amps is a prudent decision. The addition of a 600 amp emergency service provides ample capacity, assuming accurate load calculations confirm this. However, it's crucial to avoid oversizing the emergency service, as this can lead to unnecessary costs. Therefore, meticulous load calculations are essential. These calculations should account for all anticipated loads, including both normal and emergency loads. It's also important to consider future growth when sizing the emergency power system. The bank may add new equipment or expand its operations in the future, which could increase the electrical load. It's generally a good idea to provide some extra capacity to accommodate future growth. In addition to the electrical load, it's also important to consider the physical space requirements for the emergency power system. The generator, transfer switch, and other components of the system will require space for installation and maintenance. It's important to ensure that there is adequate space available before installing the system. Furthermore, the location of the emergency power system should be carefully considered. The generator should be located in a well-ventilated area and should be protected from the elements. The transfer switch should be located near the main electrical panel and should be easily accessible for maintenance. The overall design and installation of an emergency power system is a complex undertaking. It is important to work with qualified professionals to ensure that the system is properly designed, installed, and maintained. A well-designed and maintained emergency power system will provide a reliable source of backup power for essential loads during a power outage, protecting the safety of building occupants and minimizing disruption to operations. The NEC is updated every 3 years, so it's essential to stay current with the latest edition. Changes to the NEC can impact the design and installation of emergency power systems. It's important to consult with a qualified electrical engineer or contractor to ensure that the installation meets all applicable requirements of the latest edition of the NEC.